Hello, and welcome back to our Chem 4 final review. We're up to section 13, where we're going to do a sample or an example of Raoult's law. Remember, there are two gas in solution type laws. There's Henry's law that we went through. We're doing Raoult's law. So let's do an example. Calculate the vapor pressure, which is this, of a solution made by dissolving 218 grams of glucose. That's the impurity going into the water. The molar mass is 180.2 grams per mole. And they're going to dissolve that 218 grams of glucose in 460 milliliters, I hope your alarm is going off, of water at 30 degrees centigrade. You're not going to use that 30 degrees centigrade, but it is going to influence the value that they give us for the pure. Remember, the density of water is 1.0 grams per liter, and they're giving you, they have to give you this, that the vapor pressure of pure water at 30 degrees is 31.82 millimeters of mercury, and that should be setting an alarm off in your head also. Let's go. Here's the formula. The vapor pressure of the impure water plus glucose is equal to the mole fraction of water, not solute, times the vapor pressure of the pure. So first we need to find this. They gave us this. We have to solve for the mole fraction of water. So that's going to be moles of water, not solute, over moles of water plus moles of glucose. Moles of water, that's our lifesaver number 1. Because you remember, moles equals grams you have over molar mass. And for water, they gave us 460 mLs, which you know that an ml of water is a gram of water. So we have 460 grams of water. They gave us the molar mass of water. Mass over molar mass, 25.572 moles of water. 25.527 moles of water. Moles, now underneath we're going to have moles of water plus moles of glucose. So I'm going to rewrite that number down here. To figure out moles of glucose, again, lifesaver number 1. Moles equal grams you have over molar mass. Grams of glucose we have 218, and there's our molar mass. 218 over 180.2, we have 1.20977 moles of glucose. So I'm going to write that number right in here. So our mole fraction of water, meaning how much of our solution is water, the fraction is 0.95475. That's our mole fraction. I'm going to go ahead and erase this. Oops. We don't need that anymore. So, the vapor pressure of water being blocked by glucose, the vapor pressure of the impure, is going to equal the mole fraction that is water, 0.95475, times the vapor pressure of the pure, which they give you as 31.82 millimeters of mercury. Well, you know as well as I do, we never use millimeters of mercury. So let's convert that by multiplying by 760 milligrams in 1 atmosphere. Millimeters cancel. So how many atmospheres are we left with? I left it millimeter mercury.